All right, today we're going to do lesson 2.4, which is solving multi-step inequalities. Now, you should see right there at the top of your paper a very familiar sentence. What is the very familiar sentence that you see?
Don't call me after midnight.
Don't call me after midnight. And you'll notice I didn't rewrite what each of the beginning letters stand for, okay? But we are going to go over it, so if you feel like you want to write it down again, feel free in the little space that I left, okay? But let's go over, and I'm going to shorthand these, but the D in don't stands for what? Distributive property, all right? So the first thing you're going to be checking for with these problems, okay, because hopefully you've realized by now that solving inequalities is almost identical to solving equations, all right? So we're going to distribute if possible. The C in call stands for what? Combine like terms. Now you want to be careful when you're combining, all right? We're looking for like terms that are on the same side of the inequality symbol, okay? Not different sides. They've got to be on the same side in order for us to do step number 2. What does the first M, the me, stand for? Now, this is going to be really important, okay? Move the variable. It was a little easier to not necessarily move the variable to the left side when it was an equation, because switching the two sides was very, very simple. This step is going to be much more crucial when we're solving inequalities, and here's why. Remember, if your variable does not end up on the left side of the problem, we're going to have to rewrite the inequality. And sometimes when we rewrite inequalities, we rewrite it incorrectly, okay? Because we have to read starting with the variable. So this is why it's crucial, all right? It is crucial that we move the variable to the left side of the inequality if at all possible, all right? It's very, very important. Now, the A and after, what does the second, or what does the A stand for? Okay, add or subtract. So we're going to look for numbers that we need to move with either addition or subtraction, and we're going to add or subtract, making the last thing we do, the M in midnight stands for multiply or divide, okay? Multiply or divide. Now, we have one extra, I would say, step that we want to do when we're solving inequalities, all right? And you learned this in your flipped classroom last week. If the last thing you do is multiply or divide by a negative number, what do you have to do? Flip the what? Flip the sign, okay? So this is what I would do. In that space that I left you underneath, don't call me after midnight, I would add this question, because we're going to ask ourselves this question at the end of every inequality we solve. Here's the question. Do I need to flip the sign? Just get in the habit. If you are solving an inequality, ask yourself the question, do I need to flip the sign? Before you box in any final answer, ask the question, do I need to flip the sign? So that's what I would use the little space underneath, don't call me after midnight. I would write, do I need to flip the sign? Now, with those steps in mind, let's look at example 1. Solve the inequality and graph the solution. So looking at letter A, we can very quickly see, is it necessary to distribute for letter A? No, all right? Do we have any like terms to combine? No, there's no like terms on the same side of the inequality symbol. So that leads me to the M, or the moving the variable. Do we have a variable we need to move? No. All right. There's only one variable in the problem, and it's on the left side of the inequality symbol, so we're going to keep going. All right. Adding or subtracting. Do we have anything we need to move with addition or subtraction? Yes. What is it? 8. And how are we going to move 8 to the other side? We're going to subtract it. So we're going to subtract 8. And of course, we're going to cross it out, and then we're going to bring down what we have not used. So negative 9c is greater than or equal to, what's negative 28 minus 8? Negative 36. All right, that brings us to multiplying or dividing. Do we have anything we need to multiply or divide? Yes, we're going to do what? Divide both sides by negative 9. All right, very good. So c is greater than or equal to, what's negative 36 divided by negative 9?
4.
Positive 4. Now, before we box it in, ask yourself the question, do I need to flip the sign?
No.
All right, I'm hearing no's and I'm hearing yeses. What is the last thing we did to get c by itself? We divided by a negative 9. So let me ask again, do we need to flip the sign?
Yes.
Yes. if the last thing you do is multiply or divide by a negative number, okay, we don't care if our answer is negative. It's did we divide both sides by a negative number? And we did. So C is less than or equal to 4 is going to be our final answer. And now we graph that. All right, so in the center of our graph, what number is going in the middle?
4.
And to the right? 5. And to the left? 3. Now, will my circle be open or will it be closed? On what number?
4.
Closed on 4, and it's closed because it is or equal to. All right, and my arrow should be going, all my answers are less than or equal to 4. So what direction should my arrow go? To the left. Awesome. Okay? Now let's look at letter B. Distributive property, yes or no?
No.
Combine like terms?
No.
Move a variable?
No.
So we're right back to adding or subtracting. Xavier, what should we be adding or subtracting in letter B? All right, how do we move 11 to the other side? We subtract 11 from the other side. Awesome. So we bring down n divided by 2, and it's greater than, class, what's 12 minus 11? 1. All right, Kyle, we need n by itself, so what's left to do?
Multiply 3 by both sides.
3?
2.
Perfect. They're dividing 2, so we need to move it by multiplication. So n is greater than, everyone, what's 1 times 2? 2. Awesome. Now, before I box it in, question, do I need to flip the sign? No. I multiplied both sides by a positive 2, so there is no need to flip the sign. All right, what's in the middle of my number line?
2.
To the right
3.
and to the left.
1.
The circle. Open or closed?
Open.
On what number?
2.
Why open this time?
Because it's not equal to.
It's just greater than this time. So there's no or equal to, so we leave that circle open. And my solutions are supposed to be greater than 2. So what direction is my error?
Right.
My arrow to the right. Very good. All right, now I want you to take a minute. I want you to work letter C with your table. Letter C, did we have the distributive property?
No.
No. Did we have like terms to combine? No, we did not. Did we have a variable to move? Yes. Now it's very important. Remember, we want the variable on the left side. So that means we would need to move which variable term? The 3x. Okay, moving the 3x brings my variable to the left side of the inequality. So how did you move the 3x? We subtract 3x. Please, please, please don't divide when you're moving an entire variable term. You move an entire variable term with addition or subtraction. So we do 5x minus 3x, and what do we get? We get 2x, and then we bring down what we have not used. So 2x minus 12 is less than or equal to negative 4. All right, what was the next thing you guys did? We add 12. We got to move the 12, so we're going to add 12 to both sides. So we bring down what we have not used, which is 2x is less than or equal to, what's negative 4 plus 12? 8. And then how do we finish this problem? Divide both sides by 2. So x is less than or equal to what?
4.
Now, before we box it in, question, do we flip the sign or do we need to flip the sign? No, you divided, but you divided by a positive number. So there is no reason to flip the sign. Now, hopefully you can keep moving. You can graph right underneath your answer. I'm going to pull over to the side. What goes in the middle of your graph?
4.
What goes to the right?
5.
What goes to the left?
3.
Circle, open or closed?
Close.
Closed on what number?
4.
All right, and my arrow is going to the left because all my solutions are less than or equal to 4. All right, let's move right on to letter D. What do you see right off the bat we need to do on letter D? Distribute. And what are we distributing? 3. What do we get when we distribute a 3? All right, 6a. We do 3 times 2a, bring down the minus sign, and 3 times 1, which is 3. And then we bring down the rest of the problem. So it's greater than or equal to 10a minus 11. All right, any like terms to combine? No. All right, any variable to move? Yes. All right. Koi, what variable term are you going to move? 10a. Very good. We want that variable on the left side. How do you move it, Coy? Good. We're going to subtract 10a from both sides. Okay? 6a, moving 6a wouldn't be wrong, but it is going to complicate things at the end. So we move that 10a. What is 6a minus 10a? Negative 4a. Bring down what we have not used. Negative 3 is greater than or equal to negative 11. All right. Taylin, what do we do next? We're going to add 3 because we have to add or subtract. So we're going to add 3. And we've got negative 4a is greater than or equal to negative 8. All right. Elijah, how do we finish this one? All right, we're going to divide both sides by negative 4. So a is greater than or equal to what? 2. Question. Do we need to flip the sign? Yes, the last thing we did was divide by a negative. So a is less than or equal to 2 is going to be our actual final answer. Now again, you go ahead and graph underneath your answer. I'm going to graph over to the side. What number's in the center?
2.
What number's to the right?
3.
What number's to the left? What kind of circle?
Close.
On what number?
2.
And my arrow, Megan, is going to the what?
Left.
To the left. My answers are less than or equal to 2. So my arrow is to the left. That moves us on to letter E. All right, what do you notice right off the bat we're going to do on letter E? Distribute. All right, so let's go ahead and distribute. Morgan, what do we get when we distribute?
2k minus 10 is greater than, less than 2k plus 5.
All right, so we got 2k. 2 times k is 2k. Bring down the minus. 2 times 5 is 10. So 2k minus 10 is less than 2k plus 5. Any like terms to combine? Any variable to move? Yes. Does it really matter which variable we move? No. All right, so how do we move 2k from one side to the other? We're going to subtract it. All right, so we have minus 2k from both sides. Now, here's what blew my mind on some of your tests. You crossed one of them out, but you kept on the other side a 1k. I cannot tell you how many times I saw this on people's tests last week when I was grading these. All right, if it cancels on one side, it cancels and goes away on the other. 2k minus 2k is 0. So it cancels on both sides, leaving me with a negative 10 is less than positive 5. Now, let's think back to equations. When the variables cancel, we have to look at the statement left. Is negative 10 less than 5? Is that true or false? That is true. Negative 10 is absolutely less than 5. So what's my final answer when the variable's gone, but the statement left is true? Infinitely. Now, before you write this down, hold on. With an equation, the final answer was infinitely many solutions. All right. The wording is a little bit different with inequalities. It's the same idea. Any number I plug in is going to work. Okay. But here's how we word it. So I want you to write this down, and then I want you to highlight it because I don't want you to keep writing infinitely many solutions. All right. It is all real numbers. Now, you can write out the word numbers, or you can go old school with me. That is not a hashtag. That is a number sign. All right. And you can abbreviate numbers to look like mine. But I want you to highlight this because, again, yes, infinitely many solutions is the correct thought, but it's not the wording that we use with inequalities. It's all real numbers. Let's look at letter F. All right. Again, right off the bat, what do you see that we've got to do? Distribute. All right. Now be careful with this one. What do we get when we distribute a negative 4? We get negative 4 times 3n is what? Negative 12n. Now you guys know with me, I always go ahead and bring down the sign. But be careful because now it's negative 4 times 1. What's negative 4 times positive 1? A negative 4 times a positive 1 is a what? A negative times a positive is a negative. So what's negative? You say, Ms. Johnson, that's not a positive 1. It is if I've already brought the sign down. You see, I go ahead and bring the sign down. Okay? So the minus sign is already there. So what's negative 4 times 1? Negative 4, which creates something we haven't seen yet this year, a double negative. What happens when you have a double negative? They both become positive. Okay? Now, for those of you that don't do it the way I do, you don't bring the sign down, that's okay. -4 times -1 is what? +4. So however you see it, it does not matter to me as long as you end up with a -12n plus 4. All right? Again, I bring the sign down, so then I'm looking at -4 times a +1, which creates a double negative. Now, we bring down the rest of the problem. -12n plus 5.2. All right? Any like terms to combine?
No.
Any variables to move? Yes. How do I move the variable term? I'm going to add. It's already a -12n, so I am going to add 12n. Now again, please don't cross it out on one side and try to keep it on the other. -12n plus 12n is 0. It cancels, which leaves me with 4 is greater than 5 2/10. Question, variable's gone. Is that true? No, 4 is not greater than 5 2/10. So what was my final answer when this happened in equations? So what do you think my answer is going to be with inequalities?
No.
How about we can keep no solution? Okay? So there's only one change we're making with inequalities. We're saying all real numbers instead of infinitely many solutions. But no solution is no solution. So when the variable cancels and the statement left is false, it's no solution. Example number 2. Now they want us to write an inequality and they want us to solve it. We don't have to graph anything. We just have to write the inequality and solve it. So let's read through it and let's mark some important stuff. First of all, an amusement park charges $5 for admission. So there's an important piece of information. We're going to pay $5 to get in. Then they charge $1.25 for each ride. Now look at that. We talked about the word each. When we see the word each, what operation should that make us think of? Multiplication. Yes, okay? If you pay $2 for each cotton candy at the game and you buy 6 cotton candies, well, 2 times 6, you paid $12, okay? So each is multiplication, all right? Each is multiplication. So we're going to pay $1.25 for each ride. Now, you go to the park with $25. So there's another important piece of information. You walk in or you go to the park with $25. So the question is, what is the maximum number of rides that you can go on? Now, there's the word rides again. We don't know anything about the ride. We're trying to find out how many rides we went on. So what is rides going to become in our inequality? The variable, the unknown, okay? And I'm going to use an R. Feel free to use an X or whatever variable you want, but I'm going to use an R because it just makes sense. Now, here's the part that's tripping everybody up. What is the first expression going to look like? We pay $5 to get in and $1.25 for each ride. So what am I going to do? If I go home and my mom says, how much money did you spend at the park? Okay, I've got to calculate in my head. Well, I paid $5 to get in and then I paid $1.25 per ride. So what am I going to do with those two pieces of information if I'm trying to tell my mom how much I spent total? I'm going to add them, right? So what does that look like? Go ahead and write down on your paper what you think. $5 for admission and then $1.25 for each ride. What do you think that expression looks like? KK, what do you think it looks like? All right, $5 that you pay to get in plus the $1.25 times R. There's the $5 you paid to get in plus however many dollars you spent on rides. All right, now it says you go in with $25. Do you have exactly $25?
Yes.
Yes. Okay, so we know this is going to be an or equal to. Do you have greater than $25 to spend or do you have less than $25 to spend?
Less.
You have exactly $25 or less than $25. So the correct symbol for this problem is less than or equal to $25. Again, you have exactly $25, so you want to include the or equal to. Now, we need to solve it to find out how many rides we're able to ride. What do we move first? How do we move the 5? We subtract 5 from both sides. So we have $1.25 times R is less than or equal to 20. And then how do we solve for R? We divide both sides by that $1.25. So R is less than or equal to what? 16. And what's our label going to be for this one? Rides. Okay, according to what we just solved, we can ride 16 rides or less. So the label on this problem is rides. And that is lesson 2.4.